There are three forms of quadratic equations. There are vertex form, factored form, and standard form. Sometimes one form is better than the other, so in this video we're going to look at completing the square, which is a way to write something that's in standard form and write that in vertex form. So let's think about completing the square. I'm going to start a square. I'm going to call it x squared using an area model. That's 2x's and 2x's. So I have x plus 2 on this side, and I have x plus 2 on this side. I want to finish this square. What would I need to add in that bottom part? I have x squared plus 4x right now. What would I need to add in the bottom part to complete the square? Well, it looks like I would need 4 little squares. So to complete the square, I would need to add 4. Now while we're thinking about this one, I want to write the dimensions of this rectangle. This rectangle, or square, is x by 2 by x by 2. So the area is x plus 2 squared. Okay, let's add some more. Let's make a bigger one. I'm going to add, so now it's no longer 2, now it's x and 3. So we have x squared plus 6x, and I want to complete this square again. What do I need to add? How many little squares am I going to need to add to complete it? Looks like we're up to 9 this time. Now again, I want to write the area of my new square in factored form. So my sides would be x plus 3 and x plus 3, so I would have x plus 3 squared. Let's finish it. Let's take this pattern out a little bit farther. If we added 1 and 1 again, now we're up to x squared plus 8x plus something else. How much do we need to complete that square? We're going to need 16 little guys. So the area of our new square, the latest square, would be x plus 4 squared. Let's try another one. I'm not even going to draw them. You guys can tell me. How many x's would I have if I tried to make another square? I would have 10x. Now, how many little squares would need to be added in order to finish that square? I would need to add 25. That would be an x plus 5 by x plus 5 square. Now looking at these numbers, we can kind of see a pattern. What did we do? How could we get from this standard form into this nice form where factored form where everything's written as a squared? That's what we want. That's what things look like in vertex form. Do you see any relationships between the numbers in the standard form and the numbers in the factored? Hopefully, we'll pick up on the fact that what we're doing is we're taking this number right here and we're dividing it by 2 to get that number inside the factor. Then, what happens to get that last number that we went into the blank? We squared it. So, thinking about what we know from the standard form equation, we have ax squared plus bx plus c. To complete the square, what we're actually going to do is we're going to take b and divide it by 2, and that's going to get us what goes into our factor. And then what are we going to do to get that third number? We are going to square it. So b divided by 2 squared is something that's going to come up a lot in our complete the square problems. So now let's look at some to actually convert them, some actual equations with some y equals in them. Y equals x squared plus 16x minus 12. This is in standard form, and I want to get it into vertex form. So we're going to use complete the square. When we use complete the square, the first thing we want to do is move everything that's not going to be part of our trinomial to the other side of the equation. So in this case, that 12 is going to move. So now I'm going to have the equation y plus 12 equals x squared plus 16x. Now remember what we did to complete the square. We needed to add something. Since this is an equation though, we're going to need to add something to both sides. So we're going to end up with y plus 12 equals x squared plus 16x plus something, and that plus something needs to come on the other side as well. So let's use our b divided by 2. b is 16. So b divided by 2 is 8. So I know that now when we square it, we're going to get 64. We need to add 64 to both sides. What I like to do is as soon as I get that 8, I know I'm going to write this as something squared. b divided by 2 goes right into our parentheses. So we get x plus 8, all squared, 64. Now on the other side of the equation, we're going to have y plus 12 plus 64, which is 76. And we're almost done. Vertex form says that we have y equals, so we need to subtract 76 from both sides. So our final solution is y equals x plus 8 squared minus 76. So if we were to think about the vertex of this problem, we could say the vertex was the point -8, -76. And a for this equation is just 1, which makes sense because that's what it was when it was in standard form. Here's another standard form equation, and if we want to get it into vertex form, we are going to use complete the square. So to complete the square, we're going to complete the square with x squared plus 24x. So we don't need that 145 right now. We're going to move him to the other side of the equation. Remember, when you move things to the other side, you subtract. So you're going to end up with y minus 145 equals x squared plus 24x. And we're going to try to complete the square so that this left-hand side is x plus or minus something all squared. And to find that something, remember what we need to do. We need to use b divided by 2. b divided by 2 goes inside those parentheses. Squared is what we add to this side. Now, if we add 144 to one side, we need to add 144 to the other because it's the equation and we want it to stay balanced. So now our equation is y minus 1 equals x plus 12 all squared. We're almost done. It's almost in vertex form. We just need to get y alone. So we're going to add 1 to both sides. And we get y equals x plus 12 squared plus 1. That would be the vertex form of this exact same equation. If you use your calculator out and you graph the two of them, they would be the exact same parabola. Now, what's the vertex of this graph? It's -12, 1. And in this case, a equals 1, so it doesn't have any stretch to it. Where things can get tricky with completing the square is when you have an a value that's different from 1. Even when this happens, though, we start the same way. Everything that we're not going to use as part of our complete the square problem moves over to the other side of the equation. So y minus 7 equals 3x squared minus 18x. Now, when we did all of our b divided by 2 stuff, that was only for a equals 1. So we need to factor out a before we can finish this problem. So if we factor out a, which is 3, we will end up with 3 times x squared minus 6x. Now remember, we're going to add our something still, so I'm going to leave my plus something blank over there. And, oops, if I add something to one side, I need to make sure I add something to the other side. Now when we write our vertex form, we're going to come down, and I'm going to get that set up. I want to write this as something squared, and now our b is -6. That's the b we're going to look at. So we need to do b divided by 2, which is -3. Then we need to square it, which is 9. Now before you go ahead and put a 9 in the other blank, I want you to think and look at the right-hand side of that equation. Did you really just add 9? You actually added 3 times 9. So on the left-hand side, we need to put 27. Now I'm going to simplify that a little bit. We're going to get y plus 20. And we're almost there. We're almost in vertex form. All we need to do is move that 20. So our final equation is y equals 3 times x minus 3 all squared minus 20. That is the vertex form of the equation that was written in standard form. So the vertex of this problem is 3, negative 20. And this one does have a stretch. A is 3, which again makes sense because that's what it was in the standard form equation. Here's another one where a doesn't equal 1. If we're going to convert this to vertex form using complete the square, we're still going to start the same way. We're going to move that 128. So we're going to end up with y minus 128 equals 5x squared minus 50x. Now we need to factor out that 5. So we are going to pull the 5 out, and we're going to end up with x squared minus 10x plus something. On the left-hand side, we're going to make sure we write our plus something blank as well, so we don't forget to add it to both sides to keep our equation balanced. Because even though we're converting forms, we're not trying to actually change what's in the equation. We want it to still be the same parabola. Alright, so in the next line, we are going to get our squared term ready to go. And we are going to do b divided by 2, which is negative 5, all squared, which is 25. And again, be very careful. We did not just add 25 this time. We added 5 times 25, which is 125. You need to keep it balanced. You need to make sure if you factor out a, you have to put it back into whatever you add to both sides. So simplifying the left-hand side gets me just y minus 3. And then if we move that, we're going to get y equals 5 times x minus 5 squared plus 3. And we're done. We have vertex form. Now that we have vertex form, we can say, hey, this graph has a vertex at 5, 3, and this graph has a stretch of 5. This standard form equation is kind of nice. There's no a that I have to worry about factoring out. Hooray! So let's go ahead and get it started. We're going to have y plus 1 equals x squared plus 7x. We know we're going to add something to both sides because adding something is going to get me my perfect square that I can write as x plus or minus something all squared. So let's go ahead and, b divided by 2. 7 divided by 2. Well, that's okay. That's a fraction, but it doesn't change anything about the problem. We're going to add 7 halves. And we're going to square 7 halves, and we're going to put it over there. So think about when you square a fraction. 7 halves squared. What you do is you square the top, and you square the bottom. So it's 49 over 4. So my plus something is 49 over 4. 49 over 4. Now, when we simplify that left-hand side, we're going to need to add a fraction and a whole number. And when you add fractions together, you need a common denominator. So this is the same as saying y plus 4 over 4 plus 49 over 4. So our left-hand side is now y plus 4 plus 49, which is 53, over 4, equals x plus 7 halves squared. Now we need to move our 53 over 4. So we're going to have y equals x plus 7 halves squared minus 53 over 4. So we have our vertex form. Yes, it has fractions. Yes, it's kind of gross, but that's okay. We can still say what the vertex is. The vertex is negative 7 halves, negative 53 fourths. And a, in this case, there is no stretch. A equals 1. I just want to complete the square one more time so we can look at one more special case. So when we, no matter what though, we're always going to end up doing that b divided by 2 all squared stuff. But first we need to make sure our a is 1. And in this case, a is not 1. So let's go ahead and move everything where it's supposed to go, and then we'll deal with that different a. So I have y plus 64, because we're moving this to the other side. It has nothing to do with x for right now. It needs to go for just a minute. So y plus 64 equals negative x squared plus 16x. In this case, a is negative 1, and we cannot have a is negative 1. We have to have a is strictly 1. So we're going to factor out the negative 1. When we factor out the negative 1, that just means divide everything by negative 1. So we get x squared minus 16x. And we're still going to have our plus something. So I'm going to get that there. And so I don't forget, plus something on the other side. And bring down your y plus 64. Now that we have a all factored out, we're ready to go ahead and do our complete the square steps. We're going to have negative times x plus or minus something all squared. So let's do b divided by 2, negative 8, all squared, 64, and we factored out an a, so you didn't really add 64. You really added negative 1 times 64, which is negative 64. So when we simplify that side, we get y plus 64 plus negative 64. Ooh, how convenient. You're left with y equals. So we're done. Y equals is what we needed to get it into vertex form. Our final equation is y equals negative x minus 8 squared. So this parabola has a vertex of 8, 0, and it has an a value of negative 1, which means it opens down like a frown. So just to sort of recap what we do when we complete the square, is first we move everything that is not an x term to the other side of the equation. Then we look for a. If we have an a value that's different from 1, we factor it out. Next, we use b divided by 2 to write it as something squared, a binomial squared. And then we square whatever b divided by 2 is, and we add that number to both sides, being very careful if we took out an a. Then it's just a matter of getting it in y equals form. So completing the square is really handy for converting from standard form to vertex form. We're going to look at completing the square to solve quadratic equations as well, but that's going to be in another video.